How to calculate the enthalpy of combustion from calorimetry experiment. So before I answer this question, this is a past paper question from A-level exam. Let me first go through the first question. So the first question asking you to complete the equation for the hydrolysis of the triester and palm oil under acidic condition. This is a triester and in presence of water, hydrolysis under acidic condition that will give you the acid, 3 moles of the acid, palmitic acid, and also glycerol. And now moving on to answering question about the enthalpy of combustion. In a calorimetry experiment, combustion of 387 milligram of palmitic acid increases the temperature of 0.150 kilogram of water from 23.9 degrees to 37.5 degrees. Calculate the value in kilojoule per mole for the enthalpy of combustion. Remember to do that, you need to use the equation Q equals mc delta T. Well, Q represents the heat transfer during the combustion, M is the mass of water in gram, C is the heat capacity of water, and delta T is the difference in temperature. So now we need to change the mass of water from kilogram to grams, so 150 grams, and the specific heat capacity of water is 4.18 kilojoule per joule per Kelvin per gram, and the difference in the temperature is 37.5 minus 23.9. This is the difference in temperature in Kelvin. However, the difference in degree Celsius is the same as the Kelvin. So the value for that will be 8,527.2 joules. Now we need to find the enthalpy of combustion, and we get it from the equation delta H equals Q over N, which is the number of moles. So first we need to calculate the number of moles of palmitic acid. So first of all, you need to find the relative formula mass or the relative molecular mass of palmitic acid, and when you calculate it, it's 256. And then the number of moles will equal the mass of palmitic acid in grams. They give us in the question the mass in milligrams, so we have to divide it by 1,000, so it's 0.387 grams divided by the MR, which is 256. That will give you the total number of moles, which is 1.51 times 10 to the minus 3 moles. Now using the equation delta H equals Q over N, remember that this is an exothermic reaction, so you are not going to use the value of the Q in the plus, but you're going to use it in the minus, and also you have to change it from joules into kilojoules. So now the value is going to be, we change this into kilojoule by dividing by 1,000 and use the minus value or the negative value because it's an exothermic reaction. So it's minus 8.5272 kilojoule divided by the number of moles we just calculated.